All righty, today is February 13th. We have geometry class rolling right now. After today, we will be in single digits of NHA class weeks left. We'll have 9 Tuesdays, 9 Thursdays remaining. If you can believe that, we started the year with 28 Tuesdays and 28 Thursdays. And here we are after today in single digits. We'll go 7 weeks straight from now all the way until our 2 week break in April. We get the week of April 8th, the Tuesday and the 10th, Thursday off. And then the next week we have, what would that be? The 15th and the 17th off of April. And then we come back after that little hiatus and have 2 weeks left. And then we're done with NHA for the year. Done with geometry. You're more than welcome, if you've not already done so, to take Algebra 2 with me next year. I know several of you have. I know David with a Y took Algebra 2 last year. Isabella took Algebra 2 last year. And I think that's it. So those who didn't take Algebra 2 last year are more than welcome to. If you're graduating, that's cool. I think Dr. J, you're graduating, aren't you?
Yeah.
Cool. And are you going to invite us, the whole class, to your graduation?
Heck yeah, it's at NHA, guys.
Come on now. All right, NHA graduation, and looking forward to that. And also, anybody else graduating this year? Anybody going to be taking Algebra 2 next year? Thumbs up if you're taking Algebra 2 with me next year. Anybody? One. Just Gilbert. Oh, and Nathan. Good. Algebra 2 will be more fun. That phone ring's so loud. I'm gonna have to mute my audio too in a second, just in case somebody leaves me a message. So sorry about that. But we'll get to geometry once the answer machine is done. My least favorite part of recording my office is I have to mute it if. Oh, let me mute it just in case you're leaving me a message.
What the heck? Mr. Soto, your AI. What is this?
Nobody left me a message. I put my mute on just in case somebody left a message. They might say, Pastor, I'm doing this, that, and the other again. Pray for me or something like that. I don't want that to be on this because this is being recorded and uploaded and stuff. So that's why I always mute that. Yeah, I found that out last week that I have all these cheat codes for yeah, pretty cool. All right, let's do this. I was looking at the lesson today, and I know sometimes we've said this geometry can be kind of difficult, and it's maybe not my favorite curriculum I've ever taught. I think I've taught 4 different geometry curriculums, and to be honest with you, teaching textbooks is my least favorite of all the curriculums I've taught for geometry. And I've even told Mrs. Millen that when I do geometry in 2 years, we probably won't use teaching textbooks. To which you all say, unfair, Mr. Soto. Why do we have to be the ones with your least favorite curriculum? But you're my favorite class, so hey, that kind of balances things out, right? But that being said, I felt like some of the proofs have been a little bit over the top difficult and how the explanations have gone. But I'll say this, some of this is really, really easy as well. And I would submit to you that today is really, really, really easy. So the idea today is this. We're going to go teach you the concepts of 3 additional quadrilaterals. We taught you already that a polygon is a shape that's enclosed that has at least 3 sides, which means a triangle is a polygon, which also means that any 4-sided shape is also a polygon. So you have a polygon. Then when you get from polygons, you get into 4-sided shapes, and that's what we've been talking about of late. And we learned this in the 3rd grade too, by the way. Some of the stuff you're learning today, you learned in the 3rd grade. So as bad as I feel about the difficulty of this curriculum, I'm also reminded there are some lessons that are beyond elementary, maybe to make up for the difficulty of some of the other stuff. And again, if there's 22 questions on a lesson and half of them are third grade level that you're going to just breeze through, then the other more difficult stuff doesn't seem as overwhelming. That makes sense? So, so we have a polygon, which is an enclosed shape with at least three sides. Then we have a quadrilateral. A quadrilateral is any shape that's enclosed that has at least four sides and four angles. That's a quadrilateral. The term quad, of course, like a quad runner, we see quad meaning four. And so we also know that there are all kinds of shapes within the quadrilateral domain. And so we've already learned about trapezoids, which are quadrilaterals that have a base, two base sides that are parallel to each other. We've also learned about isosceles trapezoids, which means the bases are parallel and the angles of the legs are equal, which also makes, because they're parallel, which also makes the side legs equal to each other, similar to an isosceles triangle. An isosceles trapezoid has angles that are the same, base angles are the same, and so by definition. And so we've learned about the trapezoids, isosceles trapezoids. We've learned about parallelograms, which parallelograms are quadrilaterals that have both sets of sides that are parallel to each other, meaning the top is parallel to the bottom, the two sides are parallel to the two sides. We've also learned a lot of cool things about parallelograms, which is that the opposite angles will be the same. The consecutive sides would be 180 degrees. The diagonals intersect to form congruent bisectors within the diagonals of parallelograms. So those are the things we've learned already. Now we're going to learn about a rhombus, a rectangle, and a square. Again, you learned about these in the third grade, so nothing new in that capacity, but you just have to take all this additional information that you've learned about solving for X and, proofs and theorems and things of that nature, and now apply those to some simple things that you've already learned. So that being said, let me go to the whiteboard here. We'll draw some different shapes that you know. And again, then we'll get into the work today. Not too terribly difficult. So by definition, a rhombus is just a parallelogram where all four sides are the same. Okay, all four sides are the same, and so it's a rhombus. So a parallelogram could look like this, and you have this side equal to this side equal to this side. These two angles are congruent to each other. The opposite angles are congruent, and the other set of opposite angles are also congruent to each other. You take all that, and if you make these sides the same, then a parallelogram is just a rhombus is just a parallelogram with all four sides congruent to each other. Again, pretty basic. Again, all the ideas of a parallelogram exist in a rhombus, but there's a few extra things, meaning all four sides are the same. So that's a rhombus. And then I think rectangles. You learned those in the third grade. But if you think about it, a rectangle is a parallelogram, right? It's not a rhombus, though. It is a parallelogram. Because watch. This is congruent to this. This is parallel to this. This is parallel to this. The opposite angles are the same, 90 and 90. The consecutive angles will also equal 180. Watch, 90 and 90 is 180. So everything a part of a parallelogram, a rectangle, is a parallelogram and then some. The only difference is this. In a true rectangle, all of the angles are right, meaning they're all 90 degrees. Which means then that a square is kind of like the quintessential quadrilateral. because it is a polygon, because it has more than three or more sides enclosed. It is a quadrilateral because let me see if I make it a little bit, you know what I could do? No, let's try this one. All right. Hey, I can even check this out. I didn't even know I could do this. All these cool shapes I have on my computer, I didn't even do before. And make these the same. I need 120 by 120, right? To make this exactly a square. Check us out. How cool are we? And let's see how this is. Make this a rhombus. And that doesn't really look like a rhombus. Oh, because the exterior is 120. That's why. I get that. Okay. So, anyways, that being said, the quintessential uh, quadrilateral is the square because it is also a parallelogram. It's also a rhombus. It meets all those definitions. And technically, it is a rectangle also. A rectangle isn't necessarily a square, but a square is actually still a rectangle. It's not a trapezoid and it's not a rhombus. But other than those two quadrilaterals, a square is basically the sum total of those other quadrilaterals, if that makes sense. And again, not too terribly difficult. So that being said, let's take our sheets of paper out. We're going to go through this together. We're going to together do 18 of your 20-some problems. Many of these you don't even need my help to do, but we're going to do it anyways nonetheless. So number 2, it says this. A rhombus is a parallelogram with 4 congruent sides. That's either true or false. The answer to that, as I've already said, would be true. A rhombus is a parallelogram with 4 congruent sides. It fits the other criteria of a parallelogram, meaning the opposite angles are congruent. The consecutive angles are equal 180 degrees. It's split diagonal. If it's got its diagonals bisect each other to equal lines and such. And so a rhombus is a parallelogram with 4 congruent sides. So let's look at number 3 here. Again, some of these you're going to have to think a little bit on, but a lot of them are pretty self-explanatory. It says the line segment joining the midpoints of 2 sides of a triangle is blank to the third side and blank its length. So let's see what we have here for number 3. A line segment joining the 2 midpoint. Let's see. This is a long time ago. So we have a triangle. So okay. Oh, I think they want this one actually. Sorry about that. They want this guy right here. That's where I'm confused. I told you this is all easy. So the line segment is parallel and it cuts these in half. We learned that in lesson 55. Okay, so it says the line segment joining the midpoints of 2 sides of a triangle is parallel to the third side and 1/2 its length. All right, so that would be number 3, letter C. All right, number 4. Who wants to read number 4? Go ahead. All right, I'll read number 4. If the diagonal's blank, then a quadrilateral is a parallelogram. Okay. If the diagonals are parallel. Well, the diagonals wouldn't be parallel, right? Because by definition, diagonals intersect each other. They're not parallel to each other. Can't be A. They're not perpendicular either. They're not congruent per se. They would be in a rhombus, but not just a normal parallelogram. Intersect's not enough, because just because they intersect not enough, the answer has to be letter D. They bisect each other. So if the diagonals bisect each other, then a quadrilateral is a parallelogram. Let me illustrate what I mean by that. So in order to be a parallelogram, it's going to look like this. And the diagonals will bisect each other. This will be congruent to this. This will be congruent to this. Intersect's not enough, because you could have a shape like this that's not a parallelogram and its diagonals still intersect each other, but they're just not creating equal lines. Bisecting means not only does they intersect, they also create equal lines. So the answer to number 4 would be letter D. All right, number 5, why don't you do it and send me over your answer? Does anybody not have a paper in front of them? All right, it says a blank is a parallelogram with 4 congruent and right angles and 4 congruent sides. Number 5, the quintessential quadrilateral is a parallelogram. All the angles are right, all the sides are the same. And the answer to number 5, of course, is a square. You got it. Number 6, this is either a trapezoid, an isosceles trapezoid, a rhombus, a rectangle, or a parallelogram. Be the most specific. Number 6, and again, these are not too terribly difficult. These things you should be able to get on your own, I would imagine. For number 6, that would be because it has parallel bases. Pretend I drew that a little bit straighter. And congruent sides, it's letter B, an isosceles trapezoid. Number 7, that's obviously a rectangle. Again, I'm not insulting your intelligence. I didn't write the curriculum, but you can figure out that that's a rectangle. Number 8, because all 4 sides are congruent, we know that it is a rhombus. And by definition, because they are congruent, those are going to be equal. These alternate angles are opposite angles are also congruent to each other. And even though we don't even have to have it tell us that, we know it once it tells us all 4 sides are the same. By definition, it's going to have all the other criteria of a rhombus. So if you said the opposite angles were congruent of both sides, it could be a parallelogram, it could be a rhombus. But if it is a rhombus, all 4 sides are going to be the same exact size. Okay, so number 9 is going to just be just a normal parallelogram. Okay, so number 9 is E, parallelogram. So that was pretty easy on that first page. Let's turn it over. We'll have a little bit tougher stuff on the back, especially when we get down to 13 through 19. But that was as easy of work as you've done all year. Number 10, a rhombus is always, sometimes, or never a parallelogram. A rhombus, by definition, would always be a parallelogram, because by definition, a rhombus is a parallelogram with all 4 sides equal to each other. A rectangle always, sometimes, or never has acute angles. Well, if every measurement of a rectangle, every angle is 90 degrees, those are all right angles. By definition, an acute angle is less than 90 degrees. The answer to number 11 would be C, right? Never. A rectangle will never have an acute angle. Again, a parallelogram is always, sometimes, never a square. Well, since a square is a parallelogram, it could sometimes be a square, right? It doesn't always have to be. All parallelograms aren't squares, but all squares are parallelograms. So sometimes would be the answer to number 12. All right. For numbers 2 through 12, on the count of three, thumbs up or thumbs down on all that. 1, 2, 3, give me a thumbs up or a thumbs down. Again, I don't think too terribly difficult. All right. So we got that. Good, good, good. These are a little bit tougher. We're going to do the converse, inverse, and for number 13 and 14, why don't you try them? Send me over your answer while you're trying them. And remember the difference between the converse and the inverse. The statement is above select whether each statement below is the converse, inverse, or contrapositive of the following statements. Remember, converse, you're just flipping the thoughts. Inverse, you're saying the opposite of the thoughts. I just got the balloons again. The opposite of the thoughts. I wonder if on the recording it doesn't give it might not give the fireworks. And if it doesn't, that'd be weird because people would be weirded out by the things I do because they wouldn't see the graphics there, the AI graphics. Send me over your answers to 13 and 14 when you get them done. Remember, converse, you're just flipping it. Inverse, you're kind of saying the opposite. The contrapositive is the negative opposite of both. That's the contrapositive. Okay. Good job, Nathan. That's number 13. Number 14. Anybody want to try that one? The original statement is this. If a parallelogram is a rectangle, then its angles are all congruent. If the angles of a parallelogram are all congruent, then it is a rectangle. We've just converted the statement. We've just flipped it. So the answer to number 13 is A. Number B, we're saying the inverse of it. If a parallelogram is not a rectangle, then its angles are not all congruent. Letter B, the inverse of that. And I realize why contrapositive, that kind of does make sense because you're saying the double negative, but you're still stating the same facts. So you have A and B for 13 and 14. Okay, I want you to try number 15. Okay, it looks like this. A triangle whose angles have measures in a 1, 2, 6 ratio. I want you to create a problem. Make x, 2x, and 6x each of the three angles. Then those would be certainly equal to 180. Solve for x to get one of those measurements, then plug that in for the other two and give me the measurements of that triangle. So here again, 15 says a triangle whose angles have a measure in the ratio of 1 to 2 to 6. 1 to 2 to 6. All right. That looks good, Hannah. Anybody else? Make a math problem. Very good, Elisa. Good job. All right, there you go. 20, 40, 120. All right. Try number 16. It's similarly done. See if you can do number 16.
You'll need to unlock your iPhone first.
Similar. But you already have the 90 in that one. Number 16, a right triangle where one of the two acute angles measures 2 times the other. It would look like this. You already have one of them. It's going to be 90. You need the other two. This plus this equals 180. I mean, you could do a shortcut too and say these two have to be 90, so you could omit one step if you really wanted to. I'll do it the long way for your sake, though. Right? Or you could just say x plus 2x equal 90 because we already know these two added together have to be 90 because this is a triangle and the sum of the angle measurements are going to be 90. So x plus 2x equals 90, 3x equals 90, x equals 30. If x equals 30, the other angle equals 2x, which is 2 times 30. That would be 60. There's the three angles. Okay, for number 17, I want you to try this also, okay? I will do it for you, but you should put on your due diligence and try it. But I'll even help you. Okay, so let's draw the triangle. Remember, and it might not be the scale at first, but you can just go DFG. Just so you can look at it, then you can redraw it if you need to. Let me show you a few things. The largest opening produces the largest angle. The smallest opening would produce the smallest angle. Okay? So in order to find this, what you need to do is, we'll say this, FG is going to be smaller than DG. So DG has to be smaller than FG. Okay? Now let's see if the next one, DF has to be larger than DG. Okay? So let's go ahead and cut this back just a little bit. Okay. So DF is the longest side. So it goes this way. FG is less than DG, which is less than DF. DF is the biggest side because it says DF is greater than DG. Okay, so the smallest side will produce the smallest angle. Since FG has the smallest side, angle D has to be the smallest angle. You see that? FG is the smallest side. DG is the middle. DF is the largest. FG produces angle D. Angle D has to be the smallest angle of the triangle DFG. All right? Thumbs up, thumbs middle, thumbs down on problem 17 and only problem 17. Count of three. Here we go. 1, 2, 3, go. All right. All right. Okay. Again, those ones you just have to lay out. You have to order them out. It takes a little trial and error as well. So I got one thumbs down. Okay. Let me show you again then for the one thumbs down. It says this in triangle DFG, they say FG is less than DG, and they said DF is greater than DG, which means that the largest side of this triangle has got to be DF, because DF is more than DG and DG is more than FG. Okay, so we'll do it this way. We'll order FG less than DG, which is less than DF. So now we know the sides. Once we know the sides, we can create a triangle. Okay, so we'll say FG is the smallest side. We'll call this FG. Let's make DG, so we'll make D over here, a little bit longer than F. So we'll put a D here. And then we'll make this the longest of the three sides. So in my model here, I've done that. FG is the smallest. DG is the middle. DF is obviously the largest side. Okay, now watch. Look, see how wide this opening is? The big wide opening on the side makes this the largest angle. That's the biggest. Okay? Conversely, the smallest side makes this the smallest angle. So the smallest angle is angle D. Let me give you one more with a big right angle just to show you what I mean by that. We'll call this DF. We'll call it a big old right angle. We know if this is 90, it's going to be the largest angle, right? It has to be. No. Hold on one second. Has to go this way, actually. DFG. Okay. So as you can see, the largest angle here is going to be the longest side produces the largest angle. This next side is the smallest side. It's going to produce the smallest angle. As you can see, this is obviously the smallest angle of this right triangle. The smallest side produces the smallest angle. FG is the smallest side, they told us. And that makes D the smallest angle. All right, let's go number 18. Y'all, Mr. Soto, you're doing 18 of our answers for us. I am helping you. I want you to get this. Why don't you try it? Number 18. This is what they've given to us. ABC triangle. We got to find the longest side. The biggest angle is going to have the longest side. Okay? So once you think you got it, let me know. This is 35. This is supplementary to this, so that's going to be whatever that would be. Then you can figure out this angle. When you figure out this angle, you'll know whatever angle is the largest, the opposite side will be the longest side. All right, going once, going twice. Here we go. If this is 100, then this is 80. Because we know that this is supplementary. A transversal that cuts a line is supplementary. If this is 80, then this is going to be 80 plus 35 is going to be what, 115? 180 minus 115. This is going to be 65. Because of that, we're going to have, this is the smallest angle. This is the second smallest angle. This is the largest angle. If this BCA is the largest angle, which it is at 80, then AB is the biggest side because the side opposite the largest angle of a triangle is the largest. So AB or BA, either way, is the longest side number. That's number 18. Okay, for number 17 and 18, thumbs up if you get it, thumbs down if you're still kind of lost. Count of three. 1, 2, 3, go. All right. Okay, number 19 should be really easy. Pre-algebra math. We know the opposite sides of a square are equal. If they're equal, we have the same variable. Solve for B. Your younger siblings in my pre-algebra class could solve this. Why don't you go ahead and try it? 3B plus 2, 2B plus 7. Good job, Giovanna. Yes, that is the answer. All right. Not too terribly difficult, I would say. Maybe some of the easiest stuff we've done all year, in my estimation. And we will be back at it again next week. Again, 9 weeks left. We made it to single digit Thursdays and Tuesdays. Single digit weeks left, which means we have 18 more classes to go. All righty.
Goodbye, Mr. Soto. Thank you.
We will talk to you later. This is recorded if you need to watch it again, and we will see you. It'll be on the YouTube channel at some point.